Okay. The second type of the pump, the main type of the pump, is a dynamic one. Dynamic pump is increasing pressure by using rotary blades. So these rotary blades increase the fluid velocity, increase the momentum of the fluid. And when you increase the fluid velocity, you mean you increasing the total energy of the fluid. The centrifugal pump can be referred as a dynamic machines. They use a centrifugal force for pumping liquid from one level of pressure to a higher level of pressure. Liquids enter the center of rotation impeller, which imparts the energy to the liquid. Centrifugal force then discharges the liquid through a volute. The centrifugal pump is one of the most widely used fluid handling devices in the refining, petrochemical, in every industry, even in our house, buildings. We'll see the centrifugal pumps in our house, yes, the centrifugal one. And we'll ask you why centrifugal pump is used, but look at this question at the end of our lecture. Every plant has a multitude of these types of pumps operating, different types of pumps operating. For example, this centrifugal pump have one impeller, and this impeller, it is blades, just blades, is veins or blades. And this impeller, when moving, is expel the fluid and move the fluid at a higher velocity. But the idea is I'm not going to increase the velocity. I have to convert this kinetic energy increase in terms of pressure energy. And this is usually happen either in volute or diffuser. Diffuser or volute shape is part cross section of the pump that decelerates the flow. Just in the static part is just to decelerate the flow and convert the kinetic energy into pressure energy. Due to Bernoulli equation, as you know, total pressure is constant. So if the total pressure is increased, I can change part of the total pressure is dynamic type, is depending on the velocity, and the part is a static type. And in the static part, if you decelerate the flow, so automatically the static pressure will increase, and the static pressure will reading in the gauge. This pump is called overhang pump. This is a suction, this is a charge, and this is a pump rotor is supported by pairing 1, 2, 3 pairing, and this for sure behind the impeller there is a certain amount of sealing or controlling of the fluid emissions. So this is a mechanical seal or backing.
Centrifugal pumps are the most preferred pumping devices in the hydraulic world. In this video, we will have a conceptual overview of working of centrifugal pumps. At the heart of the system lies the impeller. It has got a series of curved vanes fitted inside shroud plates. The impeller is always immersed in water. When the impeller is made to rotate, it makes the fluid surrounding it also rotate. This imparts centrifugal force to water particles, and the water moves radially out. Since rotational mechanical energy is transferred to the fluid, at discharge sides of impeller, both pressure and kinetic energy of water will rise. At suction side, water is getting displaced, so a negative pressure will be induced at I. Such low pressure helps in sucking fresh water stream into the system again, and this process continues. This is the reason why priming is important for centrifugal pumps. If no water is present initially, the negative pressure developed by rotating air at I of impeller will be negligibly small to suck fresh stream of water. Impeller is fitted inside a casing, so the water moving out will be collected inside it, and will move in the same direction of rotation of impeller to the discharge nozzle. Here you can note one specialty of casing. It has got increasing area along the flow direction. Such increasing area will help in accommodating newly added water stream and will also help in reducing exit flow velocity. Reduction in flow velocity will result in increase in static pressure, which is required to overcome resistance of pumping system. Here you can see more details of vanes inside impeller. They are backward curved vanes with state-of-the-art eye configuration. This vane is extracted from a Kirloskar pump model. If pressure at suction side of impeller goes below vapor pressure of water, a dangerous phenomenon could happen. Water will start to boil, forming vapor bubbles and spoil impeller materials over time. This phenomenon is known as cavitation. More the suction head, lesser should be the pressure at suction side to lift water. This fact puts a limit to maximum suction head a pump can have. Careful pump selection is required to avoid problem of cavitation. Current impeller type is enclosed. Semi-open and open impellers are also in use depending upon application. If the working fluid is cloggy in nature, it is preferred to use open kind of impeller, but they are slightly less efficient. Mechanical design of centrifugal pump is always challenging. A shaft is used to connect between the impeller and motor. Since water pressure inside casing is huge, a proper sealing arrangement is imperative in arresting water leakage through shaft casing clearance. Mechanical seal or stuffing box-based mechanism is used for this purpose. Impeller is mounted on bearings, but at suction side of impeller, it is not advisable to fit a bearing since it will block the flow. So bearings have to be fitted at the other end. This means impeller is mounted like a cantilever. For high flow rate pumps, a bearing housing with cooling oil is necessary for improving life of bearings. We thank Kirloskar Brothers for their technical support and creation of this video.
Centrifugal pumps can be classified according to the shaft position. Shaft position, maybe it's vertical pump or horizontal pump. This is a horizontal pump, this is a vertical one. So I can call the pump horizontal pump if the shaft is horizontal, or vertical pump if the shaft is vertical orientation. We can classify the pumps in different classifications according to the bearing position, according to type of impeller, according number of impellers, according the casing design, the static part that converts the kinetic into the pressure, the static energy. So according to the fluid flow, it's coming radial or axial or mixed. These different types of the vertical pumps, as you can see, vertical can, deep well. The vertical can is the highest range of the flow and the pressure in the centrifugal vertical pump used, this one. And this one is deep well, is used in many upstream applications. The motor is down, is submerged in the fluid, and this is the impellers and the bowels. There is a sump pump. Sump pump is either only one impeller downside, the fluid coming up through this line, or the inline pump, the fluid coming here and this impeller there, and the fluid is out from this nozzle discharge, or submersible pump. Submersible pump is just one impeller, the fluid coming from here, go outside from this nozzle, and you connect the pipe to deliver the flow above the ground. Okay, according to the bearing position, you have two types: overhang pump or between bearing pump. Overhang pump have supporting the shaft from only one side. There is no pairing in the other direction, only one side. There is no pairing in this side, only one side. So it is like a cantilever shape, or cantilever supported, simply support. Cantilever supported, there is a free end, and this is the free end, is supported one. So it's called overhang pump. Or it can the pump between pairing. Between pairing means there is a bearing here and bearing there, and the impeller inside between the bearing and in the right side and in the left side, or driven side or non-driven side. And for sure this pump is much higher price than this one, due to you increase the component of the system. It's not one bearing, it's two bearing, and not one seal, it's two seals, and there is impeller inside. Okay, this is between bearing pump. According to the type of the impeller, you can classify centrifugal pump: a closed impeller one, semi-open impeller, or open impeller. Open impeller is the least efficient one, so the most used one is a closed impeller, and this is usually used except in some applications like submersible pumps that handle sludge and handle a large content of the solid particles. So if you are going to use this one, the impeller will be clogged, so you have to use the open impeller. This is exception of the application, submersible pump, but almost 90% of the application, 90% of the centrifugal pump is using this type of the high efficient one, is a closed impeller. The vanes between these plates, the blades between these plates, and this is in real application, the impeller. Or you can classify the centrifugal pump according to the number of impellers, single stage or multi-stage. Single stage means one impeller stage. Usually the impeller stage can raise the head up to 300 meters. So if you are requesting more heads than like 600, 500, so you need more than one impeller, 2 impellers, 3 impeller, 4 impellers. So single stage, single impeller, or multi-stage, multi-impeller is 1, 2, 3, 4, 6 impeller. Okay, usually the single stage impeller coming in overhang pump or between bearing, but the multi-stage pump coming for sure in between bearing type. You can classify the pump according to the casing design, how you convert the energy, kinetic energy, to static pressure, how you convert this according to the Bernoulli. There is no difference in potential energy, potential pressure. In potential, there is no difference between the suction and charge, so there is no difference. It can be neglected. So the other components of the total pressure is a dynamic one, is static one. If you reduce this dynamic, static will increase automatically. So you can increase this, decelerate the flow by diffuser. The diffuser is channels. This is static channels behind the impeller. So if the fluid is moving out from the impeller at a higher velocity, you make the cross-sectional wider. Wider means the velocity is reduced. The velocity is reduced and coming out from the casing, uniform casing, by a high static pressure and less velocity. This is a shape. This is a design. Other design is volute. Volute means there is no diffuser, just the rotating impeller, the fluid coming with a high velocity, coming out together with a high velocity, and when coming out, you see this center line is shifted a little bit about from the casing center line, so the fluid is coming with a higher area, when it's coming out from the casing is coming out through a higher area, larger area. So it's the same concept. This is a volute. Modern design is using a double volute, and double volute is just a trial to reducing the forces, radial forces on the bearing, radial forces on the rotor and the bearing. You can see this is a double volute, this is the radial forces, and this is the diffuser one, and this is the single volute one. For sure this point is what's called BEP. What is a BEP? For every dynamic pump, for every centrifugal pump, the flow range of the pump is changing, can be changed. The centrifugal pump permit changing of the flow rate. You can totally close the valve, or totally open the valve, or make it partially open, partially closed. That's charge one. For sure the suction have to be fully open usually, but the discharge valve can be closed a little bit, like the tape in the building, in the bathroom. You can open the tape a little bit or totally closed. So the pump permit a change in the flow rate. In this flow rate, this range of the flow rate, there is a certain amount of flow rate that have a highest efficiency of the pump. So the curve of the pump, the parabola curve of the pump, is coming from low efficient to high efficient according to the flow rate. There is a certain flow rate for each impeller. This one is called best efficiency point. Best efficiency point means the flow at this point the pump have a highest efficiency. We will see this later on. So the energy is coming to the fluid by pump consists of the useful energy in the form of the pressure, fluid temperature rise, and velocities. Or it may become a loss through conversion to atmospheric heat or noise. Okay. In the centrifugal pump, we express the differential pressure we asking pump to handle in terms of head. Head is a specific energy. Is the height of the column liquid that could be supported by available or useful energy. There's different examples of these centrifugal pumps. This one, suction charge, and this is overhang type. This one is single stage, and this is a bearing housing, and this is a motor, and this is a coupling cover. This is another practice of the practical from the piping. You have to consider in piping systems, the piping engineer have to consider. Usually the pumps, suction and charge have different nozzle sizing, different than the suction charge header. So how you connect? How you connect the suction? You have to connect the suction nozzle with the suction piping with an eccentric top flat reducer. This is shape is the most uniform flow shape, uniform flow one. And the charge side, you can use concentric type nozzle on larger. This is to reduce the fluctuation, the vortices in the coming fluid and losses at the suction of the pump. Usually you make a straight run before the pump and after the pump in terms of 3 diameter, 3D or 5D. 3D, the diameter. What is the D? The suction nozzle of the pump is a D. The charge nozzle of the pump is a D. This is wrong installation. This is example for wrong installation. Okay, there are different types of the centrifugal pump, either single stage or multi-stage. In single stage, we will see there is an overhang, inline, integral gear, centrifugal pump, and double flow, sump, submersible, magnetic drive. And then in multi-stage, you will see horizontal split and barrel and can, sump, submersible. Let's see together. We will discuss this flow range after we go and have an overview for different types of these pumps. The first one is a single stage overhang pump. Yes, we can see this. This is a single stage, one impeller, and overhang because the proton shaft is supported from the driven end, and the non-driven end there is nothing supporting here, just as impeller. So single stage overhang pump. This pump is the most widely used in the industry. the most widely used pump in all applications in different industries. Its construction incorporates an impeller affixed to the shaft, which has a center gravity located outside the bearing support system. Usually the first selection, the first specification, the first surveying on the market about this one. If the flow and the range and the flow and the head within the range of these pump types, we are going to purchase this type and specify this type. If it's outside, so we have to go to the other types. Single stage inline pump. This type of pump is finding increased usage in application of the low head and the flow. The advantage of this pump design is that it can be mounted vertically, what's called inline. What's online? Single stage because it's one impeller stage. Inline because you connect the suction pipe and charge pipe. So if you are going to dismantle the pump for overall maintenance, so no need to disturb the suction and disturb the charge, just unbolt or dismantle the suction nozzle, then remove the pump outside without disturbing the suction piping and charge piping. So this is the advantage of this pump, what's called inline pump. Inline pump is vertically mounted between the pipe flanges and doesn't request a base plate. However, base plate is ordered. No pump have to be ordered without base plate. A concrete or grouted support plate, however, it is strongly recommended to use a base plate. It should be noted that many inline design don't incorporate bearing in the pump and rely on rigid coupling. There is rigid coupling here to maintain pump and motor shaft alignment. Acceptable pump shaft assembly runout with these types of the pump should be limited to 0.001 inch. This is an inline pump, and we have already seen a figure. This is an inline pump. This one is online. Okay. This is a suction side. This is suction nozzle and charge nozzle in the other side. Okay, single stage inline pump. The third one is integrally gear centrifugal pump. Integrally gear centrifugal pump. This pump is used for the low flow application. Request a high head. The pump case design is similar to the inline, but incorporates a gearbox. There is a gear here. Incorporates a pump bearing. There is a bearing and integrally gear. This gear is used to increase the impeller speeds over 30,000 RPM. So what is the highest centrifugal pump? What's the highest speed centrifugal pump? The integrally gear pump. So how it's operated? It's operated through the motor delivers the motion to the gear. The gear deliver the high speed from 3,000 or 1,500 RPM to 10,000, 30,000 RPM to the impeller. So the impeller rotates at these high velocities. When it's used when you need a pump, you specify your application, your process, the system need a pump with a flow rate in terms of tens of meter cube per hour, units of meter cube of hour. That means you need 1 meter, 2 meter cube, 3 meter cube, up to 10 meter cube per hour. At the same time, you have a high pressure. High pressure mean in terms of 300, 400 meter, 30 bar, 40 bar. Within this flow range and the pressure range, the overhang pump cannot handle this flow and the pressure range. And the solution is either to going to positive displacement pump, or you can order this pump. The only problem with this pump is there is one supplier worldwide purchase this pump, design and purchase and selling this pump. So this pump is sole supplier called Sundyne. And Sundyne is a France manufacturers of this pump. And for sure this is a high pressure, a high price. Usually is a higher price. The next type of the pump is single stage double flow between bearing. Single stage, yes, is one impeller stage between bearing in driven side and non-driven side. And double flow means that impeller is two impellers back to back. So the double suction impeller are mounted on the between bearing rotors. This pump design is commonly used when the flow and head requirements make it necessary to yield low values of MPSH, pump MPSH. There are certain losses in the pump inside the pump called pump MPSH, net positive suction head. When designing the piping system for this type of the pump, care must be taken to assure equal flow distribution to each end of the impeller to prevent cavitation and vibration. So the fluid coming from two sides through the impeller then coming together to the discharge nozzle. So you splitting the flow, so you make the total loss is less than one entry. Instead of one entry to the impeller, you make two entries of the flow to the impeller. So it reduces the losses because it reduces the velocities at the suction side. So reduce the losses. It just means the pump MPSH and MPSH requested is less. Next pump type is multi-stage horizontal split. Multi-stage just means there is certain number, maybe up to 15 stages, 16 stages. When the hydraulic limits of single stage pump are exceeded, hydraulic limit mean you asking the pump to handle total dynamic head of more than 200, 300. You need 30 bar, 40 bar, 50 bar. So this is mandated multi-stage, more than one impeller. It's common practice to use a multi-stage pump between bearing for sure. This figure illustrates horizontal split. What is so called horizontal split casing? Yes, the casing design is two halves, upper half and lower half. And splitting of the casing is parallel to the axis of rotation. So it's called horizontal split casing. Horizontal split casing. The horizontal split casing design, which allows the rotor to be removed vertically, just dismantle the upper half, take it out, then pull the rotor for maintenance vertically. After the top half casing is unbolted. This type of the pump have limited operating condition. What is the limited operating condition? This type of pump is normally limited to the working pressure of approximate 2000 psi and temperatures up to 600 Fahrenheit and specific gravity of 0.7 or greater. This means if the surface need more than 2000 psi, if you are going to pressurize the liquid with a pressure more than this, so we cannot use this pump, we cannot specify and order this pump. And if the temperature of the liquid more than 600 Fahrenheit, or the fluid is like LPG, if this LPG, if the light product, if the light liquid have a specific gravity less than 0.7, 0.6, 0.5, so you cannot use this pump. So this pump design. A better configuration for this type of the pump can be either online or opposite. You can arrange the impeller in line, in series, or opposite, back to back. The opposite impeller arrangement has the advantage of not requesting a thrust balancing device, which is requested for the inline configuration. There is another aspect of this pump, you have to take a note about that. When you use this pump, we usually make the nozzles, suction discharge nozzles, we asking the vendor to manufacture the pump, make the suction discharge nozzles in the bottom half of the pump. Why? Because it's easy in order not to disturb the suction and discharge piping while you do maintenance on the pump and unbolted the upper half and remove the rotor. So no need to disturb the suction and discharge piping. Multi-stage barrel pump. Multi-stage barrel pump, it is the highest pump can be used in the centrifugal type. It's also called barrel design, barrel pump. It's used for surface condition exceeding those normally considered acceptable for horizontal split casing, used for less specific gravity, less than 0.7, for more temperature, liquid temperature more than 600 Fahrenheit, or for more pressures more than 2000. So it is a higher price. At a higher price, it costs you more than axial split. Thrust balance device is requested since the impeller configuration is almost always in line series. Circular mounted end flange results in excellent. That's why it can be used for the light product. The low viscosity, the low density. The circular mounted end flange results in excellent repeatability for tight joint as compared to the horizontal split case design. So barrel pump is a double casing pump. One casing, inner casing, is containing the rotor and or rotating and stator part of the pump. The outer casing is including the seal, the bearing, housing and the nozzles. So the two casing inside is including the rotor, the impellers and the outside casing, this outside casing containing including the suction discharge nozzles, the bearing housing, the seals. And we are going to dismantle this pump. You have to open this casing perpendicular to the shaft radial split, what's called radial split. You have to remove this cover and pull the inner bundle. So this is a circular and mounted end flange, this one. This is a horizontal pump. What about vertical pump? Vertical pump, the first one is a vertical canned pump. There are variety of the vertical pump types and design. Use of the vertical pump is usually dedicated by low available MPH. So the question here, when we use the vertical pump. Okay, the selection procedure, the first selection and specification in pumping system is single stage overhang pump. You survey the market if it's okay, so you are going to purchase this one. Usually you specify the horizontal pump first, and we are not going to the vertical pump unless two reasons. The first one is the net positive suction head available of the system is very low comparing to pump MPH, and the pump MPH for the single stage you are getting it from the vendor's data, and we will do this later on. So if the MPH available, net positive suction available, is very low, you have to make artificial static head by using vertical pump. This is the first reason. The second reason of using vertical pump is application, like the sump. There is no pump used to make a suction lift, like make it the pump horizontal pump above ground and make it the piping down and make a suction lift. No, we didn't rely on this configuration in the pumping system design. So we use in the sump there is an open drain system, in the closed drain system there is a vessel, there is an sump. We use it for this sump a vertical pump. Okay, the first stage impeller can be lowered. The can type design is one of that widely used in the petrochemical industry in the vertical application, in the vertical pump application, particularly when pumping low specific gravity liquids from the tank farm facilities. Usually the low viscosity or low specific gravity liquid have a low net pulse of suction head available. The multi-stage can pump is comprised of the number of bowl. What is a bowl? Bowl is the number of impellers. This bowl assembly is containing one impeller. Each bowl is containing one impeller. This reduces the risk of the hydrocarbon leakage to the atmosphere. Lubrication to the sleeve bearing located throughout the length of the shaft is provided by pumped liquid. Therefore, bearing material versus the product compatibility must be always be considered. Yes, if you are going to use along the vertical shaft, there is a sleeve that support the shaft from buckling. So this sleeve bearing need lubrication. If you are going to use the liquid, so the liquid characteristics, lubrication characteristics have to be considered. If it's compatible or not. If it's not compatible, you have to inject, have to use another lube oil, and you have to use another external source to lubricate this bushing. It's necessary, however, to prevent leakage where the shaft passes through the can to connect to the driver. Sealing is normally provided using mechanical seal. This is the configuration of this pump. These are the bowls. You can see the bowls. And this is the bowls. Each bowl have impeller, 1 impeller, 2 impeller, 3 impeller, like that. This is inducer. Inducer is certain element that used to reducing the losses at the inlet of the impeller. It reduces the MPH of the pump. So you fill this can, vertical can, this is the can, external. You're filling the can with the liquid and you have sufficient net pulse of suction head available with respect to the first stage impeller. The first stage impeller C can use this MPH to pull the flow and move it through the shaft and coming out from the charge nozzle. This is the outer, this is the can, and this is the head. Second type of the vertical pump is the sump pump. Sump pump, it is a popular design for handling runoff streams of the rainwater, non-corrosive or corrosive liquids. The setting limitation for this cantilever design, yes, cantilever, because you have one impeller here and the fluid coming from there and going through the charge line above the ground. This plate is supported above the ground and this is submerged in the liquid. This is a motor and this is a gear, this is a coupling, and this is the backing or the seal. So the setting limitation for this cantilever design is about 3 meter, 4 meter. If you are going to use, you need pump with more length or more in the sump with more depth than 4 meter, you cannot use this type of the pump because it is only supported by the motor or the bearing upside. This particular design incorporates the enclosed line shaft with external lubrication to the bottom bearing. Along the shaft, these are the sleeves. These sleeves can be lubricated either by grease, automatic greaser, or by the pumped fluid. Okay. Next one is submersible pump. Submersible pump is widely used in sanitary application, sanitary and sewage application, and this type of the pump using an open impeller type. This type consists of the electric motor is coupled directly to the impeller or bowl assembly. All the components are designed to submerge it, so this pump usually coming with mechanical protection IP67 because the pump and the motor is submerged in the liquid. The pump is installed at the bottom and or the bed of the sump, so the fluid coming from here and is going to move in, connect the pipe to reach the above ground. In the past, this type of the pump didn't find widespread used in the refining petrochemical industry. However, with increasing environmental restrictions, this type of the pump is being used more frequently in the refining and petrochemical industry. Magnetic drive pump. All types of the pumps must have a backing or the mechanical seal. Mechanical seal or backing used to control the emission. If the fluid coming out from behind the impeller, it will going out to the loop oil system or the bearing, or coming out to the atmosphere. And for sure you have to control the leakage from the pump. As long as the shaft is continue from the pump to the motor. The other way of the sealing pump is the sealless pump. Sealless pump who has no seal because the shaft is two parts, two halves. The shaft is not continued from the pump going through outer from the pump and going to the motor. No, it's called magnetic drive pump. The magnetic drive pump, as a result of more stringent environment constraint regulation, that means you handle a hazard fluid, flammable fluid. So the sealless pump technology has gained prominence, and such a design is a magnetic drive pump. This design, such as a motor shaft, is attached to the power frame of magnet drive pump by means of flexible or rigid coupling. The outer magnet and the shaft assembly supported by its own bearing. Alignment requirements for this type of pump are similar to those for horizontal mounted centrifugal pump fitted with mechanical seal or backing. The sealless pump is generally applied when there is a need to contain toxic or hazard fluid. This is a cross-section drawing of this pump. You can see this, the shaft is not continued, so this is the impeller and this is the shaft, then stopping here. There is an outer magnet and inner magnet. So different pole, if for each revolution the poles is different. When the magnet pole is changed, so the inner will be changed. Then there is a rotation due to different magnetic field. North and south, north and south, north and south, make it the inner shaft rotates as the outer one is rotating. So this is the main idea. So there is no need to install a sealing because the shaft is not continuing to go getting out to the motor. Okay, let's see the flow and the pressure range of each type. General one, and the pressure range of the different types of the centrifugal pumps. The single stage overhang pump, we can see this up to 300 psi and 800 foot, and the flow up to 7000 GPM. If you are going to go to the next pump is a single stage double flow, so we will see this no change in the head and the flow because there is one impeller, but the flow rate is becoming 10 times the single stage overhang one. And the single stage aligns the same, it's the same flow range and the pressure range of the single stage overhang. And the integral gear, we can see that this pump is accepting integral gear pump. You can accepting more flow and more head than the single stage overhang one. This is in favor of high speed impeller. It can reach 2500 foot. And the multi-stage horizontal split pump. Multi-stage horizontal pump is giving you more head and more or less the same flow, or less. Multi-stage means that you can install 1 to 3 stages up to 17 stages. So you can get 10 times the head produced from the single stage. And the multi-stage barrel pump, it's in the same way. And we can know that it is it can accept more charge pressure and higher temperature of the liquid and less specific gravity. Vertical cam pump is it is the high range of the vertical one, vertical cam pump. The same pump Some pump is just a small pump, about 100 psi, and submersible one is the same. And the magnetic drive pump have a limitation of the single stage overhang pump. These are the different flow ranges of the different types of pumps. Okay.